Today we are going to be talking about solving a systems of equations, specifically a linear systems of equations by substitution. All right? And so, guys, why we just learned how to solve by graphing on the first day. And guys, solving by graphing is great when your equations are both in that y equals, right? So solving an equation, it's great when you're both in that y equals, or if you get it into y equals. But guys, sometimes your numbers are just too big, all right? Or your numbers might just be like obnoxious and they might not show up on the graph very well, all right? Other times, it's actually a little bit easier to do it by substitution. So what I'm going to do is I'm going to write the steps for how to solve by substitution kind of over here on the left. And then I'm actually going to do it with the equation over here on the right. Okay? So the first step is that you need to solve one equation for a variable. And this is only if it's needed. All right, guys? And so I'm going to rewrite this. This is going to be our example here. 3x plus 4y is equal to 24. And my second equation is going to be y equals 2x minus 5. All right, guys? So substitution really works best when one of your equations is already solved, so you don't actually have to do the first step. And so, guys, what you will notice is this second equation here, y equals 2x minus 5, it is already solved for y. Do y'all feel good about that? So that is our first step. We are done, okay? So you look at it and you recognize, okay, one of my equations is already solved for a variable. And your second equation, hence the name of the method, is you are going to substitute the equation, the whole equation from step 1 into the other equation, okay, for the variable. So hang with me on this. A lot of times we substitute in a value, like a number. But instead of substituting in a number, we are literally going to substitute this whole equation in, 2x minus 5, for that y. So now, so we're going to substitute it. The y is equal to 2x minus 5, so I'm going to plug that whole entire thing in for y. So that's going to be 3x plus 4, not 4y, but 4 times 2x minus 5. And that is going to be equal to 24. Do y'all feel good about that? So instead of substituting in a value, we're literally substituting in the entire equation of 2x minus 5. Y'all feel good about that? Awesome. So now the beautiful thing about this, guys, is when you look at this new equation that we have, what is not there? A y. So now, can we solve for x pretty easily? Yes. So guys, that is our step 3. You solve for the remaining variable. Sometimes it's x, sometimes it's y. Sometimes it's A, sometimes it's B. It depends on what our variables are named. So then we go here, we're going to solve for our remaining variables. So this becomes 3x plus 8x minus 20 equals 24. Do y'all feel good about that? This right here, most people do this step where they do 4 times 2x, they get that 8x. But they forget to do the 4 times the negative 5 to get our minus 20 there. So now we're going to put these guys together. So that is going to be 3x plus 8x is going to be 11x. Are you guys comfortable with that? Minus 20 equals 24. We add our 20 to both sides. And we have 11x is equal to 44. So y'all, what can I do now to solve for my x? Divide by 11. So x is equal to 4. Are y'all comfortable with that? So far, so good? Okay, once you have solved for your remaining variables, so I guess I'm not doing a great job of checking these off. Awesome. We solved for our remaining variable. Now we use this value, that value from 3, and we plug it in to one of our equations to find the y value. So guys, our step 4 is you use the new value from step 3 to find the other variable. All right? So I'm going to kind of jump over here to the side. And guys, it doesn't matter which equation you use. You can use either one. I could plug in this 4 for the x right here in the first equation, or I could plug in the 4 for the x in the second equation. I would recommend plugging into the second equation, because then all you got to do is multiply and subtract. If I plugged in my 4 to the x in this one, I'd have to multiply, subtract, and then divide. Does that make sense? There's a few more steps, but you would get the same answer. So I'm going to kind of write it off to the side here. So, or you can write it underneath. But it's going to be y is equal to 2, not x, but 2 times 4 minus 5, right? Sorry guys, it's kind of tiny. So guys, instead of y equals 2x minus 5, I did y equals 2 times 4 minus 5. So that is going to give me y is equal to 8 minus 5, which is y is equal to 3. Do y'all feel good about that? So that is our step 4 here. And then last but not least, our step 5 is you just write the solution as an ordered pair. So in this case, my solution would be 4, 3. Are y'all comfortable with that? So I'm going to write it in my lovely little colors here. So it is 4, 3. That would be my solution. So those are our 5 steps of how we solve by systems, or by substitution. You basically substitute in the equation, and then once you solve for the value, then you go back and you substitute in the value. So we're like substituting in twice. The first time we're substituting in an equation, the second time we're substituting in a value. Now, I want to show you guys, there's a couple ways you can check yourself, okay? So one way that you can check yourself is by going here, cleared that memory, is you can go here, and guys, in that top equation now, I'm going to use my 3x plus 4y, and we're going to see if it's equal to 24. So 3x plus 4y is equal to 24. So it checks out. Does that make sense? So I plug both of these values back into the top equation, and I see that it works. If I plug both these values into the second equation, we already know that works because that's what we did right here. Okay, guys? So I plug it into the other equation to make sure it works. What's another way that I could have solved this system, you guys? What's another way we could have solved this? Okay, how could we have done it on the calculator? Could we have graphed this? Well, can we graph this guy? Y equals 2x minus 5? Yeah, so I'm going to graph 2x minus 5. Can I graph this top equation? Not like that. What would I have to do? I'd have to get the y by itself, so I'd have to subtract my 3x and then divide everything by 4. Y'all comfortable with that? So it would be negative 3/4 x plus 6. So if I was going to solve for y, that first equation would have looked like this. And when I graph it, guess where these two lines intersect? At 4, 3. So y'all, if we actually calculated the intersection, second trace, intersect, enter, 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 look at the intersection it gives us, 4, 3. Do y'all feel good about that? So guys, really, for this particular equation, it would have been almost just as easy to do it by graphing because it was set to that y equals already. Does that make sense? But if you prefer to do it algebraically with substitution, that's awesome. Today we are going to practice doing these primarily by substitution. All right, y'all? So let's take a look at a couple more examples here. All right, so let's see here. For my first official problem that I'm going to give you, number 1 here, we are going to say x plus y is equal to 38, and x is equal to 2y minus 25. So guys, for this particular problem, would graphing this make sense? Is anyone solved for y equals? No. So guys, for this particular problem, substitution actually makes the most sense because it's going to take the least amount of manipulating and changing your equations. But this time we don't have a y equals. What do we have? X is equal to this 2x minus 25. So we're going to plug it in for that x there. Do y'all feel good about that? So this is going to become 2y minus 25 plus y is equal to 38. So y'all, did I really need the parentheses around that value? No, but I just want to make sure that we understand we're plugging that entire equation in for x, okay? So when there's no coefficient, you don't really need the parentheses, but I'm just going to always plug it in with the parentheses so that if there's a negative or a coefficient or something, I'm already in that habit, okay? So now I'm going to plug in now I'm going to simplify this. So we have 2y plus y, so that's 3y minus 25 equals 38. I'm going to add 25 to both sides. That gives us 3y is equal to 38 plus 25 gives us 63. Divide both sides by a lovely 3, and my y is equal to 21. Do y'all feel good about that? Any questions on how we found the y value there? Now that we know our y value, what do I do to find the x value? Does it matter which one you plug it into? For this one, they're kind of the same in terms of hard, right? You could plug in 21 here, or you could plug in 21 there. It's not a big deal, okay? So if I'm going to plug in my 21 onto the second equation, I'm going to say x is equal to 2 times 21 minus 25. So that becomes x is equal to, what is that? 42 minus 25. So my x is equal to 17. Do y'all feel good about that? So my ordered pair, so those are the two values. So what is the ordered pair of my solution here? 17, 21. And then I'm going to go ahead and do, I just like all my colors. You don't have to have all the colors, but does that make sense, guys? So that would be my ordered pair. And how I could check myself is I can go back up here to my x plus y. And guys, what is x plus y supposed to be equal to? According to the first equation? And guys, what is 7? It's supposed to be equal to 38. And 17 plus 21 is definitely equal to 38. So it works for both equations. Does that make sense, y'all? Everyone tracking? Okay, cool. Now, this one's not going to take up as much room. I'll draw a lovely little line here. So I'm going to do a number 2. So we are going to have two lovely equations here. Y is equal to 4/3 x minus 7 and 4x minus 3y is equal to 15. All right. So we have a y is equal to 4/3 x minus 7. So I'm going to take this whole lovely guy and plug it in for the y right there. Are you guys okay with that? So that is going to be 4x minus 3 instead of y. I'm going to say 4/3 x minus 7, and that is equal to 15. So then that becomes 4x minus negative 3 times 4/3 is going to give us negative 4x, and negative 3 times negative 7 gives us a positive 21. And that is going to be equal to 15. But what happens here, y'all? What happens to my 4x minus 4x? Our variables all canceled. And what are we left with? Is this a true statement? Is 21 equal to 15? No. That is a false statement. So guys, if it is a false statement, how many solutions will we have? No solutions. So guys, this is a lovely little special case. When you have a false statement like that, then there are no solutions. Because, y'all, if we had actually changed this guy into our slope-intercept form here, if we'd subtracted our 4x divided by negative 3, that would have been y equals 4/3 x minus 5. And guys, if we graphed those two, what would those lines look like? 4/3 x minus 5, not minus 56. What do those lines look like when we graph them? Parallel. Do parallel lines ever have an intersection? So guys, in this particular case, our lines are parallel. So they have no solution. Does that make sense, guys? So there are special cases. So guys, if you're graphing lines, no solution looks like parallel. If you are solving it algebraically, no solution looks like a false statement. Does that make sense, guys? You track in the two different ways that looks. Okay? So what I want you guys to do right now is I would like you guys to go ahead and do, I'm going to give you two problems that I would like you guys to do on your own, and then we will check our answers here in just a second, okay? So I want you to do them by substitution, all right? So I've given you these two lovely problems, so I want you guys to do these guys by substitution, all right? Let's take a look at what they actually look like when we solve them algebraically. All right, so for number 3, we should have had this lovely, we plugged in our negative 3x plus 3, and I guess I forgot my little arrows, so I'll add those in now. So I did my little negative, so that was negative 6x plus 6. There we go. Fix it on that one too. So that became 9x minus 6x plus 6 equals 7. Then I plugged it in there, and my x was equal to 1/3. All right? And then when I went back and substituted in my 1/3, I had negative 1 plus 3, which gave me that y is equal to 2. And guys, how you can check yourself, you can always check yourself here, oops, not there, is by going in and saying, okay, 9 times 1/3 plus 2 times 2 And that should equal 7, which 9 times 1/3 is 3. 3 plus 4 is 7. Does that make sense, guys? So that's a great way for you to check yourself. All right, here we plugged in our x, we plugged in y minus 3 for our x value. And when we did that, our variables canceled. All right? But what we were left with was a true statement. And when your variables cancel and you're left with a true statement, you have infinitely many solutions. Do y'all feel good about that? If your variables cancel and you're left with a false statement, you have no solutions. Because, guys, if we graphed these two lines, they would be exactly the same. If we had solved these both for y, they both would have been y equals x plus 3. So if we had solved these both for y, we would have gotten y equals x plus 3. Do y'all feel good about these substitution problems so far? Yes, no, maybe so? They're not too bad, okay? So now what I'm going to do is I'm going to do a lovely word problem with you guys, okay? So we are going to set it up, and you guys don't have to copy down the word problem, but I do want you guys to copy down the equations that we get from this, okay? So we're going to try to create the equation. All right. So the perimeter of a rectangular wooden deck is 90 feet. All right, guys, so we know perimeter is 90 feet. So this is going to actually require a little bit of pre-knowledge here. What is the equation for perimeter, y'all? P is equal to 2L plus 2W. You guys good with that? So that requires a little bit of pre-knowledge. The deck's length, L, all right, so I'm going to say L is the deck length. I like to label my variables. L is 5 feet. Ooh, I'm going to put this 5 over here so it's all on one line. 5 feet less than 4 times the width, W. So we're dealing with the length and the width. The deck length and the deck width. Write and solve a linear system of linear equations that can be used to determine the dimensions in feet of the wooden deck. So guys, we need to write 2 equations, all right? So one of my equations is probably going to have to do with this lovely perimeter. So guys, if I have 2L plus 2W, what is that going to be equal to? What is our perimeter? 90. So they give us one of our equations, don't they? And then, y'all, this guy right here, I'm just going to kind of put this 5 over here so it's all together. The length is 5 feet less than 4 times its width. So this is how we're going to get our second equation, is the comparison of these two. So the length is 5 feet less than. What does that mean we're going to be doing? Subtracting that 5. So guys, we are going to be subtracting 5 from something. What are we subtracting it from? 4 times the width. So that would be 4W. Do y'all feel good about that? Now, do we have 2 equations? We certainly do. And guys, is one of them solved for a variable already? Yes. So guys, our length is solved for this variable. So we are going to take it's solved for this 4W minus 5. So we're going to take our 4W minus 5 and we're going to plug it in for the L. So this becomes 2, not times L, but 2 times 4W minus 5 plus 2W is equal to 90. So we replaced our L, our length, with 4W minus 5, because that's what our length is equal to. Now I can solve for W. So this becomes 8W minus 10 plus 2W equals 90. So then we go here, and that is going to be 10W. And then are y'all cool if I just add the 10 over? All on the same step there. 8W plus 2W is 10W. And so 10W is equal to 100. So y'all, what is my W equal to? Yeah, the W, or the width, is equal to 10 feet. Y'all cool with that? Now, how are we going to find the length, y'all? You just plug the W in for the width, the 10 in for the W. So I'm going to go over here. I'm going to say, okay, length is equal to 4 times 10 minus 5. Oops, y'all can't see that. Sorry. I'll zoom out. So now my length is equal to 40 minus 5. So my length is equal to 35 feet. Do y'all feel okay with that? Excellent. Now, guys, what I want y'all to look at is, guys, how can we check to make sure that's actually correct? You can plug them both in to see if the perimeter is actually 90 feet. Well, guys, let's do it. So if we do 2 times 35 plus 2 times 10, that should give us 90. Is that the correct perimeter? Yay. All right, guys, so that is the way that we can kind of check ourselves as you guys plug it back in. All right, so now, guys, what you are going to be doing is I'm going to be passing out a paper. All right, and so on this lovely paper, you guys are going to be working in partners. All right, and how this is going to work, guys, is y'all are going to have 5 questions. There's 5 problems on the front of this paper. I want you to do these by substitution, the substitution method. One partner is going to do all of the A problems. One partner is going to do all of the B problems. The answer to A and the answer to B should be the same. So you work number 1, your partner works number 1, and they both should get the same answer. All right, guys? That works all the way down. So I want you guys to do that. So on this front page, y'all, everyone's getting their own piece of paper. You only have to do 1/2. Does that make sense, guys? You pick A, do all of the A problems. Your partner picks B, they do all of the B problems. Guys, on the back here, there are word problems. All right? I'm just going to flash these up because I don't want to give you all too many of the answers. Do all 4 word problems. Set them up first and then solve. This is how you set them up. All right? And then you solve them. First, I want you to do the ones on the front, and then we're going to do the ones on the back there. All right? All right, so occasionally you might get some where you're already set up in y equals. That would make the most sense to go ahead and graph both of those into your calculator and find it that way. Or you can also set them equal to each other because you're plugging in this y for that y. So then we had 4 is equal to 7/4 x minus 3. So I'd want to eliminate that fraction. So that would be what? 16 is equal to 7x minus 12. I would add 12. So 28 is equal to 7x. So my x is equal to 4. And then I would use this. Well, I already know what y is equal to. Y is already equal to 4. So this guy would be 4, 4. And then for this guy, we go here. Negative 0.5x minus 2 is equal to negative 2x plus 4. So I'm going to add 2x to this side, add 2 to that side, and we have 1.5x is equal to 6. Divide by 1.5, and here we also have that x is equal to 4. Then I'm going to take my 4, sorry you couldn't see it, take my 4 and plug it in probably to this guy right here. So y is equal to 0.5 times 4 plus 2. So y is equal to 2 plus 2, which y is also equal to 4. So you will see you will get the exact same answer on the right side and the left side. So the answer for number 1 is 4. And that kind of helps us see how we can solve there. So I did both of them, but you only need to do one side, either the A or the B side. All right, good luck.